I put off installing a Megasquirt on my Miata for years because of this list of unanswered questions. There are a lot of resources for NA Miatas, but there are not a lot of resources showing how to install a Megasquirt on an NB Miata. Here's my list. First, should I go with something like an Innovate that's plug and play for my wideband, or should I go with something like an AEM that's a little less specific and more general? For testing my sensors, will I know that my wideband and my intake air temperature sensor are working before I start my engine, and how can I verify this? Next, what if I try to start my engine without a working wideband? Is this bad? Could I damage my motor? What happens when my wideband says that it's heating? When you first start it up, it says heating and it goes through this phase. Can I start my motor when it's in that phase, or do I have to wait until it's heated up before I start my engine? When I calibrate my wideband sensor, how will I know that it's calibrated accurately? Should I install a redundant wideband in addition to my factory O2 sensor? Or should I install the Megasquirt at the same time as my new wideband? Will I lose my air conditioning when I install a wideband? And if I use air conditioning, am I going to need separate tunes for when I'm using my AC? Do I have to splice into my OEM engine harness when I'm installing the wideband sensor or the intake air temperature sensor? How does Megasquirt compare to some of the other standalone ECU options? Is it better or worse? And which one should I go with? Should I make provisions to switch back to my OEM ECU in the event that I can't tune my engine properly? I'm going to answer those last two questions right now. Once you go Megasquirt, you're never going to go back to your OEM ECU. After about an hour of auto tuning, your car is going to run better than it ever ran from the factory. There are so many resources available for the Megasquirt online. That's why I would always go with the Megasquirt over other options. Unless you have a buddy who owns a tuning shop and he owes you a bunch of money, go with the Megasquirt. It's not difficult. If you know how to connect some wires and work on your car somewhat, you have what it takes to install a Megasquirt. And I'm going to show you everything you need in this video to set yourself up for success. Let's get started. This is my 2001 NB Miata. This is the factory O2 sensor. That's the narrowband. You can see right there. Further downstream, I installed another O2 sensor down there, and I did this for experimental purposes for this video. This is the wire for the factory O2 sensor. It's all still wired up. This is the factory intake air temperature sensor. And looking into the interior, I installed the wideband gauge to look at my AFRs when I start the engine using the stock ECU. Also, I still have my mass airflow meter installed and it's still working and connected to the ECU. The reason I'm doing this is because once you get the Megasquirt installed, you'll never be able to see what the factory ECU did on initial startup. So I'm gonna be using this for my own reference, and you can use it for your reference as well. So I'm about to start it. This is gonna be a cold start. So when I start it, this wideband O2 sensor is gonna heat up, so it's not gonna be initially reading, but we'll see what the RPM goes to, and then once the wideband heats up, we'll see what the AFRs are. So here we go, cold start. The wideband's heating up. All right, so we're at 14. And right now in my garage, it's pretty warm. So this is reading pretty lean actually. I usually see like 12 and a half. I did it the last couple days and it was colder in my garage the last couple days. I think it was 40 degrees. And when I was starting it then, when it would start, the AFRs were around 12 and a half. And then it would slowly start to come up to the stoichiometric 14.7. You saw when I started it, this went up to 2000 RPM. Another thing I'm gonna do is turn the air conditioning on and see what happens to my AFRs when an instant load is applied to the system. So I'll make sure this blower is set to something reasonable, hit the AC and see what happens. See how it jumped up to 16 or something like that? It got lean. Well, first it got rich and then it got lean. But this is a good reference because once you have the Megasquirt installed and you're making changes, you're gonna do things and wonder, is this right? Is this wrong? And this will be really helpful. Another thing you wanna do is rev the engine and just see what happens to the AFRs. All right, so if I rev it, what just happened? So I'm gonna do it again. So initially when you rev it, it gets really rich. And then as you let off the throttle, it goes super lean into like 120 AFR. And even just a little blip, a little throttle blip, and it'll do this exact same thing. It doesn't have to be a lot. That's normal. This will slowly get down to 800 RPM. I'm gonna shut it off for now. You do not have to install a wideband before you install your Megasquirt. I did it just because I had never done an aftermarket ECU, but I'll show you in this video, you really do not have to do this. And there is a way that you can install the wideband, the Megasquirt, and the intake air temperature all at the same time. And before you ever start it, you'll know that your sensors are working. I was gonna uninstall all of my wires and reinstall them all for this video, but I think it'd be more confusing than me just showing you the wires, and I'll show a wiring diagram in a few minutes. The first thing I'm going to do is permanently uninstall the OEM narrowband, and that's the one I showed at the beginning. It's just this wire right here, and it's the sensor right there. Here's the OEM O2 sensor harness. I just want to point this out. These two black wires, those are the heater wires of this O2 sensor. And then one of these other wires I think is like a ground, and the other one is the signal wire. I think the blue wire is the signal wire. Undo this connector. These can be kind of tricky to get out, but I've taken mine on and off so many times it's pretty loose now. I think I might have just broke it loose right there. Here it is. Here's my wideband O2 sensor that I'll be installing, where I just took that O2 sensor off. And I just previously said that I had it installed in a redundant location, and I just removed it. It's not really relevant to the video. I'm gonna install it right where the OEM O2 sensor was. You wanna be careful when you're installing these because you could get the wires twisted up. Here's that wideband installed, and then tighten it up. This is a 19 millimeter. I'm not gonna go super crazy with it because I'm gonna be turbocharging this car in a little bit, a couple weeks here. Here's the wiring harness coming from the wideband sensor, and this doesn't have to be spliced at all. So this goes right into its own harness that goes into the back of the wideband gauge. And this plugs into here. This runs through the firewall and it goes right into that gauge. It's just popped together. And then you want to keep it clear of the exhaust. I'm probably gonna zip tie it somewhere over here. Here's the old O2 sensor. It was plugged in right here. So these wires ultimately feed back into the ECU wiring harness, and this sends signals to the ECU. But now we have nothing plugged in here. The wideband is right here. But these wires are still running back to the ECU. So if you have Megasquirt, these wires run right into the Megasquirt. The sensor was initially feeding signal wires through this blue and white wire on the OEM sensor. So it would send signals back through this blue and this white back to the ECU. Now we have nothing plugged in there, so we are not using those wires for anything. So what you can do is feed a signal using the wideband O2 sensor's wires. You can feed a signal back through this into the ECU. The wideband O2 sensor has this dedicated wideband harness that goes directly into the O2 sensor. But there's also these additional wires that you end up feeding back through the firewall. This has a white wire and a brown wire. The white is a 5 volt DC signal, and the brown is a negative 5 volt DC signal, and they're proportional to the output of the wideband O2 sensor. So you can take these two wires that are coming from the back of your gauge and feed them right back into the original factory harness. I've seen a couple mentions of people splicing into their harnesses, but you don't have to splice. This connector I just bought it off eBay. It's an oxygen sensor extender. This connector feeds directly into the factory connector. So you can take this and connect it right here. On this side, the red and the white, now those are my signal wires. So the blue one is the signal. So it changes to red at this harness. If I follow this back, red turns into white. White turns into brown. Brown is my ground. The white is my positive signal, which goes to red, which goes to the blue of the original harness. This is probably confusing. Again, that's why I don't really want to show this just with wires. I'm going to post a wiring diagram and I'm going to go through it in a second. Here's the wiring diagram I put together, and this is the AEM wideband gauge, and this is inside the car interior. It has this harness, this dedicated harness that goes right from the wideband to the gauge, and you don't mess with this harness at all. This is that one direct harness. It's called connector B. So you leave that one inside your engine bay, and this other harness, I call this the whip. A whip is just a bundle of exposed wires, and these have a wire loom wrap around them, and these run into the engine bay as well normally. So you take these and you strip back the red and the black wire out of the wire loom, and you run these back into the car interior. Here's the gauge, and here's this harness with the red and the black wire, and you give this a power source. So you can give this any ignition power source from inside the interior of the car, cigarette lighter, power window. I used radio wires, but you can use any wires you want that have enough amperage. And then you take this harness and this white and brown wire here, these two, these are always sending the passive 0 to 5 volt signal. And you take those and then you get this eBay extender and you connect right into that. And that comes with its own plastic connector that connects into the OEM connector. And then you feed that right back into the ECU. In this case, it's going to be the Megasquirt. That's shown right here. And that's consistent with the description that I just showed. If you want to know the next level, here is a relay, a Bosch style relay, and I'll post the description in the description of this part number. And you can take, again, the same ignition source, and you can energize the coil side of the relay, and then it'll close this. You can use a 5 amp fuse, so you'll have a fused wire coming from your battery that you can power your gauge with. And you can also add a bus bar, which is just a connection that you can connect other things to, and you could power a bunch more gauges. But if you did that, you'd probably want to upsize this wire and bump up the fuse size for that. But if you want to see that, it's otherwise it's the same wiring as the example that I just went through. It's a little bit more complicated, but it's the right way to do it. And I'm going to post this drawing in the description of this video. Download it, use it. Once you look at it for a couple seconds, it'll make a lot of sense. I think it's a really clear drawing. The next thing you need is an intake air temperature sensor. And I already have this installed, so I'm not gonna reinstall the whole thing. All I did was take the top of this air box off, drill a hole in here, and I got this bulkhead fitting, and I siliconed it in there. And then here's my air intake temperature sensor. Here is the factory intake air temperature sensor. You just unplug this one. Unplugged, tighten this guy up. Don't have to go crazy with it because this doesn't have to be airtight. Plug the sensor in. This is a GM air intake temperature sensor. It's what most people use. And the good thing is about this is it has no polarity. You can use these little spade connectors. And that's what I did. I added these on. And I'll show you a kit in the description that I ordered off Amazon. You can plug these spade connectors right into the original OEM connector. And it's a really good tight fit. And then you're going to want to tape it off and maybe come up with some other sort of permanent solution later on down the road. The next thing I'm going to do is remove my OEM ECU, and it's right here underneath the driver's side footwell. This is the ECU. There's this bracket here with one bolt that you have to take off, and then up there's another bolt. And mine's not there right now because I didn't want to reinstall it completely. There's a bolt up there that's kind of hard to get to, but you have to take that off too, and then the ECU should drop down a little bit, and then you can start to get these connectors out. So it's the 2 bolts and then these connectors. I'm gonna take this bolt off right now. It's a 10 millimeter. There's a little retaining bolt or piece of metal up there, and it will prevent the ECU from dropping down, so you might have to like finagle it and get it off that like little post thing up there for it to get down here and give you some room to get these connectors off. Here's the factory ECU. This is that lower bolt right here that you saw originally. And when you turn this around, there's these 2 screws you have to take out. And I already took out this one here, and you can see that I notched this out. This is the custom bracket. You have to notch it out so you can still access this expansion port. That's what this is right here. And I'm not gonna be using this in this video. This is for the vacuum line, which I'll be showing in a second. And then this is a DB9 serial connector, which is essential to operating the Megasquirt. This is how you communicate with the computer. So you're gonna have to run a cable from there, and then this is where the factory ECU wires plug right into. I went back and I beefed up this connection so it's 2 big screws instead of 1 small screw, and it's a lot more rigid like this. Before you install your Megasquirt, if you're considering using a Bluetooth wireless adapter in the future, you need to energize pin 9. And to do this, you have to make sure a jumper is installed on the Megasquirt board. You have to open it up, it's a couple of screws, and then put the jumper in place. I think it comes with the jumper on. I had a lot of trouble connecting with the Bluetooth adapter. I think it's only good if you use your cell phone, but I'm not really sure. I ended up just sticking with the hard serial wire. I installed this short little stubby adapter cable, and this allows me to plug into stuff next to the ECU. Otherwise, you have to like fish around back there and get a new connector in there. And there's also not a lot of room between this and the firewall. Next thing you want to do is run a vacuum tube, the vacuum tube that is supplied by your Megasquirt. You want to take it and just run it through your firewall. I already made a little hole in this rubber boot with a box cutter. And then you can just feed this through. And then once you feed it through, you just find it underneath your firewall. The NB has this little port on top. It has a little cap on top of the intake manifold. Take that off. And then you take your new vacuum line and you can plug it right in there. It would be difficult to show this all on a video, so I'm just gonna explain to you what I'm doing. The ECU is gonna mount basically the exact same way as the old one. So it's gonna sit vertically like that and use that same bolt hole up against the back right there. It's gonna mount the exact same way with the wires in the front, just like the original ECU. But you have to connect that little vacuum tube. So I have the tube right here that I just fed through the firewall. It's gonna connect to that port. And this is your DB9 serial connector. This is actually a male, interestingly enough. And this is a female. So you plug a cord in. I have a cord and I literally just have it ran right through my center console. It goes that direction. And I have it sitting on my passenger seat. You can route yours however you want. You could have it literally just like hanging down here while you debug your system, and that's what I did. And then I eventually ran it that direction. Connect that, connect the vacuum tube, and then you wanna connect all your ECU wires, and then you bolt it in after you get everything connected. And then you zip tie to one of these holes. Use a zip tie to secure it to any other piece of metal up inside your footwell, and there are a lot of options. Here's the Megasquirt installed. I already connected the vacuum hose to the back of it. I still have to put that nut on and then zip tie the top. Installing the ECU puts you in a really uncomfortable position. This is how you're gonna have to lay probably. And after an hour of this, you will never want to do this again. Here's the top zip tie. And then I also threw a zip tie around the vacuum tube back there to keep it in place. You don't want it to get pinched by this pedal. So there's the clutch pedal. I actually put a zip tie through there as well. So that zip tie will probably end up getting crushed at some point. This pedal comes down right here. So you don't want that vacuum tube in the way of that. I'm reiterating this, but there are 2 wiring harnesses coming off the back of the wideband O2 sensor gauge. So this one is going directly to the wideband O2 sensor, and this is the other wire harness right here. And this one is the one that we use to send a signal back to the ECU. There are 4 wires here. 2 of the wires are not here. It's because those 2 wires are the power positive and the power negative. To supply power to those, I used wires inside my radio. You could also use, there's a window switch here that has 12 volts, or you could use a cigarette lighter. You need a power source that is on when you just go like this. The key's on, the car is not running, but we have power. And see how this says heat? Clearly I have power to this. You can use a voltmeter to figure out what circuits have power. And the proper way of doing this is to use a relay. So you would energize the coil of a relay, and the coil will be energized by whatever is on. So in this case, I use these radio wires, and it would close the relay, and then you would have a fused circuit that tied into your battery that would feed the power of whatever device it is. At some point, I will switch all my aftermarket devices over to a relay-based system, but right now I just have a couple of gauges going on, and they don't draw a lot of current, so I'm not that concerned about blowing a fuse or melting a wire. To get my center panel out, I usually just pull on this. There we go. This whole thing slides out. This is how it looks when I pull this center console out. This black wire right here, that's the wire that goes directly to the wideband O2 sensor. And this other wiring harness right here is the one that goes inside the engine bay and sends the signal to the ECU. And these red and black wires, these are the power wires. This is how I identify power sources. I have my voltmeter plugged into two wires that I think are gonna come on when the ignition is on. The key is on, the car is not running, and I'm checking these wires out, and now we got 12 volts. So those are two wires that will probably work for us. You can test this before you put this all back together, but at this stage, you should be able to turn your key on. Your wideband O2 sensor should turn on. So mine's heating right now. It clearly has power. And mine's still reading an AFR because I ran my car before, but yours might not read anything. It might just have like a bunch of lines across. We have our intake air temperature sensor wired up correctly. We have our wideband that has power, and we're sending those two signal wires back into the ECU, which is now the Megasquirt. And we also have the vacuum tube installed. Now is the time that you want to hook up your Megasquirt to the system, and you use this DB9 cable that we already hooked up to the ECU. And this is I think it's called an F chip. I think it's made by FTDI. And there's a couple different versions of these. I just got mine online. And you want to make sure that your computer can communicate with this. There are a lot of videos on the topic. There are so many other videos on this topic that I don't want to cover things that other people have already covered. One good channel is OG Ped Xing, and then another channel is the Car Passion channel. Start it up, you should be able to start Tuner Studio. And if you're starting off with a base map, your ECU is already gonna have a loaded map in it from DIY Auto Tune, and it will work to get your car started. And you might have to create a new project. I'm just gonna load an existing project of mine, and my project is really close to the default. Tuner Studio started. I have communication with my ECU. If I didn't, it would be like obvious. If I turn my key off, it'll say offline. Clearly, there's no communication between the two. There's only communication when the Megasquirt's on. So I can turn the Megasquirt on just using the ignition and get feedback from all my sensors. Go to fuel settings and go to AFR EGO control and open this up and make sure that this EGO 1 port is set to O2 in and that it's set to wideband. I think you can go up here and select other sensors like narrowband, disabled, whatever. When you initially start a project, I think it asks you what sort of sensor you want. And if you install the wideband, just pick wideband and then go to this AFR EGO control screen and make sure it's set up like this. Yours might be set to simple or no correction for this algorithm. If it is, it's okay, just leave it. Once you're done setting this up, click burn. I'm not gonna click burn because I didn't make any changes. Go back to this screen. My AFRs are displaying here and they match my gauge. At this point, yours might not because your car might have been sitting for a while. So if your air-fuel ratio gauge says like 25 or something, it might not jive with what's on the screen. Or if it's not reading at all, it's probably not gonna show anything on the screen. But that doesn't necessarily mean you wired something incorrectly. When you're on the screen, you wanna go up to here, go to Tools. You wanna unlock calibration. I think mine is already unlocked. Yeah, it is. It says unlocked. If yours doesn't say unlocked, unlock it. This is probably the least intuitive part of this whole process. You have to calibrate your wideband O2 sensor. And to do that, to calibrate your wideband O2 sensor, you have to go to calibrate AFR table, which is air fuel ratio. So that's under Tools. So click that, open it up, and it gives you a bunch of different options. It gives you so many options that it might give you the impression that whatever you have is going to be in here, but that's not necessarily true. I'm using an AEM 3003 X series, and you would think that maybe the AEM 3042 is that one, or maybe the ones below it. None of those are mine. What I had to do is I had to select custom wideband, custom linear wideband, and linear refers to the equation that represents the wideband. So this is my product literature. If I look in the product literature, it's 0 to 5 volts, and here's the scaling formula. So it multiplies it by this factor, the voltage, and adds something on. This is just the equation of a line. So it's basically y equals mx plus b. Open up a Excel file, and then you come up here and you enter the exact equation that's in your documentation. At 5 volts, this is gonna give me air fuel ratio of 19.18. And then at 1 volt, so I'll make it 1, that will give me 9.6875. You just have to go in here and set yours so it matches the calculation that you just did in Excel. This is like 2 points, and with these 2 points, you can make the equation of a line. You can make this 3 volts, 4 volts, and I think it would just extrapolate using a linear relationship. To verify that everything is working right, if you're reading 16.3 AFR here, you better be reading 16.3 down here. Now, if these are off, you know something is wrong. Go back up to tools. You have to calibrate your TPS, that's your throttle position sensor, and there are so many videos showing that. I'm not going to. You just basically don't press down on your pedal, then you do press down, and you just click like record on each setting. It's really simple. You don't have to do anything here. Go to the thermistor tables. This table, you have to calibrate all your temperature sensors. For your coolant temperature sensor, the documentation that comes with the Megasquirt is excellent. This is from the DIY Auto-Tune site. Open this up. Here's the installation guide. Read this guide, it's like 2 pages long, and go through this whole guide and read every single word. Every word in this guide is extremely relevant. Read this whole thing. Once you get the car started, you have to adjust your base timing, and there are a lot of other videos showing this, so I'm not gonna cover this. Down here for this sensor calibration, this is the factory sensors, which you probably still have on your car, and you wanna make sure that your coolant temperature sensor has the same numbers, see the -4, 104, 176, and you wanna make sure it matches this table exactly. Come up here and click this and go to your air temperature sensor, and that's the sensor we just installed. That's the GM air temperature sensor, and just make sure this says GM, and this section says that GM intake air temperature sensors can be used with the defaults in Tuner Studio. Write to your controller, I'm not gonna write. Now come up here, click tuning and dyno views, and make sure you're on this fuel tab. See here, this is my manifold air temperature, 74 degrees. That means mine is definitely reading correctly because my thermostat is set to 72 degrees. Just want to make sure it looks like a reasonable air temperature. If you didn't have your intake air temperature sensor installed, this would be defaulted at 70 degrees. It's interesting to note that the manifold air temperature is often a lot higher than you think it would be. I'm inside my garage right now, and I think it's like 70 degrees in here, and the manifold air temperature is 86. But I've seen that temperature at around 70 degrees when it was really cold outside, like 30 degrees out. Another thing to look at is to make sure that you have some sort of reading for your fuel load. That's reading 99 kilopascals. I'm just gonna go 99 kPa to PSI, and 99 kilopascals is 14.4 pounds per square inch. Atmospheric pressure, 1 atmosphere is what normal pressure is. 1 ATM is around 14.7 PSI. We're slightly less than regular ambient pressure, and it's just because of the weather in Wisconsin right now. This guide refers to these 2 cooling fans, and this is extremely important as well. So this one, the output is PWM2. So go back to your Tuner Studio and come up here to basic load settings, and this version of Tuner Studio has a fan control section. So click this and make sure that it says PWM output 2, fan control on, and fan control idles up. Yes, you want all this selected, and this means that it's being controlled from this screen to PWM output 2. The secondary fan, this next fan, is set to injector 1 output channel, and these are just Megasquirt's output channels.
So they could be anything you want. You could program these to anything you want. The default condition is over 200 degrees Fahrenheit. You're gonna want that fan to turn on to cool down your coolant. So come back here and go to Advanced Engine. Up here, you wanna go to Programmable Outputs number 1. And if you were to set PWM in this table, it would give you some error. It would say PWM output 2 is being controlled somewhere else. That somewhere else is that fan page that I just showed you. So go down to here to injector output 1, and then you have to set these conditionals so that if your coolant is greater than 200 degrees and your RPM is greater than 800, then you're gonna wanna turn this on.
Hey everybody, making these videos takes a ton of time and a ton of effort. If you would do one quick thing for me, it would mean the world to me. Please subscribe to my channel, and then after you subscribe, hit the little bell notification and turn on all notifications. This would help me out immensely. I don't post a lot of videos, but when I do, I make sure they're really high quality, so I'm not gonna be blowing up your notification inbox or anything like that. But this will boost my channel in the YouTube algorithm, and it'll help me out so much. Have a good day, keep crushing it. Thank you.
A question that I had before any of this stuff was, what happens when I start my car and this thing starts to go through its warm-up phase, but the engine started? Is that bad? It's not bad, because when you start the car, it's in what's called open loop operation. I'll show you what that means here. This is your fuel VE table. What this means is that here's your engine load on the Y-axis, and here's your RPM. Your motor knows its RPM based on the wires that are already wired up to the engine harness. So there's a speed sensor that tells what the RPM is at of the motor, and this fuel load on the Y-axis is determined by that pressure that you put onto your intake manifold. So at every location on here is a certain thing, or a certain load. So if you're running at 7,000 RPM and you're pulling like a ton of pressure, that's gonna be at a really high load condition. So this is basically a dimensionless value that it's just sending an increased duty cycle to your fuel injectors. So an 80 is a lot of fuel. You know, down here when you're under lower RPM and low load, that fuel is diminished. It's way less. So depending on where you are on this table, it's gonna send a predetermined amount of fuel to your motor. There's two different tables. So this is one table. This is for open loop operation. There's also closed loop. Now we're gonna go to this fuel table, AFR table. There's another table, and this is called your air-fuel ratio table. We installed that wideband O2 sensor, and the reason we installed that is to measure the results of the combustion event of the engine. This is basically operating blind. It sees the pressure of the manifold, it knows the speed, and it sends a predetermined amount of fuel into the engine. This is measuring what happens after the combustion event. From environmental effects, irregularities, whatever the combustion event produces might be different from what you want the engine to be running at, which is generally around 14.7, which is stoichiometric. This table corrects what this table is doing. And this correction is called closed loop operation. So all it's doing is it's looking at these cells and it's saying, oh, we're a little bit too rich and we're gonna lean out the fuel delivery, or we're running a little bit too lean and we're gonna make it run a little bit rich and we're gonna add a little bit more fuel. So this is closed loop. When you start your car, it's actually not even using this main fuel VE table. This is the table that your car is gonna use when you initially start it up. Go to idle VE settings, and this is the idle VE table. It actually is not gonna use your main VE table. It uses a really simplified version of it. So it's this little cube. So this is your fuel load on the Y-axis again, this is your RPM on the X. So after you start your car, this is what it's going to be sending your engine. It's not gonna be controlling it in closed loop operation. And yours might have something else set here for PID idle activate. Just leave it for whatever it is initially until after you get it started. And then once you finally get your engine started and it's running okay, you can use all the other videos that exist on YouTube. I'm just trying to get you guys started. If everything looks like it's good to go and you're getting signal to your manifold air temperature and you're pretty confident that you got your wideband installed correctly, you can start it. And even if you don't have your wideband wired correctly, it's okay to start the motor. You just won't know what your AFRs are. But again, it's gonna be running an open loop anyway, so it's not a huge deal. If it's wrong, just turn your engine off and then troubleshoot the wideband. So I'm gonna start it up and we're gonna see what RPM it hits. So mine hit 2,000 or 2,500 maybe. My AFRs right now are 11.7, so it's pretty rich. I generally run mine rich just for safety. I'll start to make that leaner over time. OG PetXing has a video where he shows you how to make custom dashboards, and that's how I made the dashboard here. So right now, this is showing that I'm at 1100 RPM, so I'm sending this amount of fuel. If I wanted to make this leaner, I could change this cell, so I could make this, you know, whatever I want it. And there's all these different enrichment things going on when you start your engine when it's cold, and it's all adjustable in here. And I'm not gonna go into it in an extreme detail. I just wanted you to get your car started. At this point, if you're to this point, what you wanna do right now is verify your timing. And there are multiple different videos on this, or you could just read the guide. This guide from DIY Autotune explains exactly how to do it. Then you're on your way. For the air conditioning, go here. So start up idle and go to air conditioning idle up. Set this to on this table. Make sure all these settings are the way this looks. And if they are, you should be able to just use your AC on the car. So for an NB Miata, there's nothing additional that has to be done. And right now my AC just turned on. In order to get a lot of the features to work, you want to turn on your vehicle's speed state settings. And to do that, come up to advanced engine and go to speed and gear sensors. Open this up. On an NB Miata, this is incorrect. The default value, it was 40,000, and the 40,000 is incorrect. You want to remove a 0 from this pulses, so it says 4,000. If this is not corrected, it'll say that you're not moving when you are actually moving. First, set that up. All these other default values should be fine. Come up here to basic load settings and go to engine state settings. Open this up and make sure that the use VSS is enabled. Close this. One other thing you want to check is go to basic load settings and go to mass air temperature air density table. Open this up and look at this curve. The default curve is correct based on the math. The density of the air is a function of temperature. But the problem is if the temperature gets above like 80 degrees, it starts to pull a lot of fuel and your car will run super lean. And usually this is just because the temperature is getting heat soaked. So the temperature of the sensor is increasing, but the actual temperature of the air is not increasing. I had to trim this off. So I had to make it so above 80 something degrees, it basically just gives me 100% of my fueling. If I didn't do that when my car was idling, it would become really lean. If you successfully got your car started, you got your timing fixed, and you have all this stuff set up, the next thing you want to do is throw some loom wrap over your wires to protect them. And then you want to make sure that all your wires are out of hot streams and away from hot engine components. You want to zip tie some of this stuff out of the way. And you want to make sure your vacuum tube is out of the way of anything hot and isn't going to get pinched anywhere. And then another thing you can do is, since you're not using this mass airflow meter, you can disconnect this and just leave it disconnected. And another thing is you can install a short ram air intake and free up some horsepower. The minute I mentioned air intake, I had to build one. So I had this cheap intake sitting around from eBay and I threw together with some parts. This is the filter that I'm going to be using on my turbo setup in a couple of weeks. Here's the setup I'm running for my auto tuning. I had this little like police style laptop holder, and then with my cigarette lighter I'm powering this 120 volt charger for my laptop, so I can drive around indefinitely and charge it while driving it. The laptop mount just mounts to the bolt on the bottom of the seat rail, and it's pretty rigid. I've taken some probably 1.1 G turns with it and it hasn't fallen off yet. Another thing I wanted to mention is once you get this up and running, you're gonna want to do this auto tune. So go over here to Tune Analyze Live, click that, and it will not allow you to do auto tune if a couple of conditions are not met, basically. So one of them is if you're still in your idle VE table, it's not going to let you do auto tune. If the air fuel ratio is out of range, it's not going to let you do auto tune. Throttle position, there's a couple different things. It's interesting because you have to be moving in order to start the auto tune. Hold on, there's a car right on my ass. Right now I'm stationary, I'm at a stoplight. So if I start it, it's gonna say idle VE active, and it'll keep saying that, and it won't ever start the auto tune if I just leave it. So I'm gonna stop it, and I'm gonna restart it once I'm moving. I didn't have my VSS enabled in this clip, so I'm gonna start my auto tune right when I'm moving. And you can see it says acceleration enrichment, O2 out of range. It doesn't always collect data. You can see that on the lower right-hand portion of the screen. And then you can see where it says the max cell change. It's about to tick up. I apply the changes and I save them to my ECU after I stop the auto tune and I'm not moving anymore. There are so many other little things I learned throughout this process, like setting up the fuel injectors and setting the PID loops. My background is I'm a controls engineer. If you want me to make another video, just let me know. Thank you for watching.